are metabolic controls and myogenic controls. And most of it is done reflexively via the myogenic mechanism. All right. Myogenic means what? What's myo mean? Prefix myo?
Muscle.
Muscle. Okay, so this means muscle originating. Yeah, and the other one is metabolic, and that just simply means chemicals that are released as a result of metabolism. And these would fall under autoregulatory mechanisms. So if we let the cross-sectional area of a vessel increase, in other words, we increase the diameter of the vessel, that's called vasodilation. Is there a way to actively dilate blood vessels? Is there a way to actively dilate them? How would we actively dilate a blood vessel? What's that? Sympathetic? Repress? I just could. Oh, suppress. Okay, so we decrease the sympathetic ANS, and I'll agree with you that that does cause vasodilation. However, I'll disagree with the concept of calling it active. Okay? Active implies muscle contraction, okay? And we don't have a mechanism to expand a blood vessel actively. We have to do it passively. So you're right. The first part of what you said is absolutely right. We reduce or relax sympathetic stimulation, and that means that the smooth muscle in the vessel wall relaxes. And now the vessel dilates because of the pressure inside of it. Right? There's pressure pushing on the walls of the vessel trying to get out. And if we relax the smooth muscle tone in the vessel wall, then it dilates. But that's not the same. That's not active dilation. That's passive dilation. We can actively constrict and we passively dilate. And there aren't any exceptions to that. So things that cause inhibition of smooth muscle will be vasodilators. Okay? Chemicals that inhibit smooth muscle will be vasodilators.
Can you repeat? You said we actively...
We actively constrict and we passively dilate blood vessels.
What was the last thing you said? Any what? A smooth muscle?
I'm sorry, what was the question again?
What was the last thing you said about smooth muscle?
So things that inhibit smooth muscle contraction will be vasodilators. And so they give you a list here of some chemicals. Substances for metabolically active tissues. Okay. Well, H plus there, that's the functional ion in an acid. So that's telling you that acidic conditions will cause vasodilation. Potassium ion. Potassium ion can cause vasodilation. Next one's a big one, adenosine. Adenosine. That's a vasodilator. And some pro-inflammatory compounds like prostaglandins and histamine. It didn't list carbon dioxide in here, but it could. Okay, carbon dioxide belongs in that list.
So these are all...
These are vasodilators.
Yeah, so passively they do actually...
So that they would inhibit smooth muscle and let the vessel dilate.
So when they inhibit smooth muscle, is it active?
Mm-mm.
No?
No. Active implies muscle contraction. That's all active means.
Okay.
It's not that the body's not having a response. It is. It just, active means muscle contraction. Nitric oxide also belongs in this list. NO, nitric oxide. So it turns out nitric oxide is one of the most powerful vasodilators. So there they list nitric oxide. Interesting story with nitric oxide. Nitric oxide is the only gas that's actually been shown capable of binding to a receptor. We didn't think that gases could activate receptor proteins, but it's been conclusively shown, as much as you can prove anything in science, that there are receptors that can actually bind to nitric oxide like a ligand. And that was very, very surprising.
That wouldn't have anything to do with generating an action potential, would it?
Not that I know of. I mean, I won't say no, because it seems like you do enough research and everything's connected to everything, but I'm not familiar with the role in that. Okay. She asked whether or not nitric oxide could have a role to play in exponential generation, and my answer was, not that I'm familiar with. Okay, but
Well, binding to a protein, what effect would that have if it were to bind to a protein?
well, so it can actually change gene expression inside the cells
Oh.
by activating a secondary messenger system, and then we alter gene expression.
Could that help in like cancer treatments, or would that cause like abnormalities?
You know, I don't know enough about the signaling pathway involved to be able to give a good answer for that. I'd have to look it up. All right, some things that can function as vasoconstrictors. Okay. Well, they give you the most important one right here, endothelium. Endothelium. It's a small protein that your epithelial cells that line your blood vessels are always releasing a little bit of. Okay. And as it says here, the two main players in your autoregulatory mechanisms are the interplay between nitric oxide and endothelium. Give you an idea here, guys. In skeletal muscle, okay, skeletal muscle releases a lot of nitric oxide when it's under metabolic load. So that causes the blood supply to the skeletal muscles to go up because it dilates those local blood vessels. Heart does the same thing. Okay. They kind of ensure their own flow by releasing a lot of nitric oxide. And yeah, this is why if you take like a nitrate pill, like they have for treating pectoralis angina, that's why they work. Okay, it gets into the heart, it causes the coronary blood vessels to dilate and relieves that transient chest pain. We will come back to this endothelium concept in the next chapter when we talk about clotting. Probably the most confusing thing in the blood chapter we need to talk about is clotting. And I've told you before that when you slow down blood flow, that's what precipitates clotting, right? We've said that before. Well, our blood vessels go through something called vascular spasm, where they actually constrict and dilate and constrict and dilate. And they do that to stimulate clotting. It's endothelium release from the blood vessels that are damaged that really causes that. Okay. The myogenic control. The myogenic control, really, we've studied this before. This is kind of the same concept as Starling's law of preload. Okay. You stretch muscle, what does it do as far as its contractility? Does it go up, go down, no change? What? Right, yeah, you stretch muscle a little bit and it contracts with more force, and that's true with smooth muscle too. So it's kind of like the rubber band concept, except it's muscular. If you think about this for a minute, okay, I go run up the stairs. Is my cardiac output going to go up?
Yeah.
Oh yeah, I'm going to pass out by the third step. So the cardiac output's going to go up. Is my renal blood flow going to go up? Okay. Well, it might. You know, if my cardiac output goes up, my renal blood flow is going to go up. But do I want my renal blood flow to go up? Is the point. No. While I'm trying to run up the stairs, I'm not really that concerned about producing urine at that particular moment. So really, I'd like the blood flow to my kidneys to go down, even though cardiac output is going up. So you can imagine how this might go. I go run up the stairs, my blood pressure goes up, the blood coming out of my heart increases. It's going to send more blood everywhere, right? So it's going to go through my conducting arteries, the elastic ones, and then the distributing arteries, the muscular ones. The renal arteries are some of the biggest muscular arteries in the body. Blood's going to go off to the kidneys, and it's going to stretch them. Okay, that increased blood flow is going to stretch those, and as a result of the stretch, the arteries now constrict. Right? Just as it's a reflex. Okay, so you stretch the muscles and it constricts with more force, and it chokes down the blood flow. This is the main autoregulatory mechanism for most of your organs. Okay, unless there is some either nervous or metabolic control that's overriding the myogenic system is in charge. Okay, if for some reason the blood flow goes up, the arteries constrict a little bit to restrict the blood flow. Now, if they constrict and all of a sudden the kidney starts releasing adenosine, because the kidney's like, no, I need blood. And so the kidney starts dumping adenosine out into the bloodstream. Now the myogenic control is going to be overridden. And it's going to go, well, okay, I guess I'll dilate, right? And then it'll let blood flow resume. So the organs themselves actually regulate their own blood flow for the most part, okay? Now the brain's in the driver's seat, so if the medulla oblongata of the brain decides, nope, I don't care, kidney, you're not getting blood, it can go ahead and override the metabolic control via parasympathetic stimulation, and then it can cause it to constrict. Well, actually, I'm sorry, there'd be sympathetic stimulation to the kidneys, would then cause constriction. So the first order of business is the myogenic reflex. That's what's usually in charge. And we could say under non-stressed conditions, okay? Second is the metabolic controls can override the myogenic if the organ needs more perfusion. And then thirdly, the autonomic nervous system can override both the other two, if need be.
What was the second one?
So myogenic is the normal reflex that controls blood flow. The organs can produce metabolic compounds that can cause dilation. So the second one would be metabolic. Metabolic can override myogenic. And neural, autonomic neural, can override both of the other two. Okay. So it's pretty fascinating, really. You know, it kind of works like how you'd like an ideal company to work. You know, the higher ups want to teach their underlings how to do the job, and those guys want to teach the people under them how to do the job, and they don't want to hear from them. And ordinarily, they want to just work. And then the only time they hear from them is when something goes wrong, and hopefully the middle management can handle it because the upper executives don't want to be bothered, right? And then if something is really wrong, then the upper executives, well, ultimately their head is on the chopping block if things really fail. And so now you're up to the brain at that point. There's a hierarchy to it. There's a reason for that. It's an efficiency thing, right? A company works best if the people who are trained to do the job just do it. If they're well trained and they do it, they don't have to involve the manager every time, right? Anybody ever have the job of being a manager? I tell you what, middle management to me is the absolute worst job on the planet. You have no real power, but all the responsibility. You know? And so the worst type of employee, if you're a middle manager, is the one that you've had an employee like this if you've ever been, where it would be easier if you just said, you go stand over there and I'll do the job, you know, and you find yourself wanting to do that sometimes, but you can't do that because you have to train them to do the job. And sometimes parenting is exactly the same way, you know, you got kids and you're just like, you just do it like this, okay? You know, but you got to get them to do it. So, and once they do it, then that makes your life easier because you don't have to constantly look over their shoulder. So, what's the guy who's trying to do it all the time for regulation of blood flow to the organs? Myogenic mechanism. So blood flow goes up, the myogenic mechanism tries to restrict it, right? Okay. And vice versa, I didn't say it, but if blood flow drops, then the myogenic mechanism works in the opposite. Then it just relaxes to encourage blood flow. Now you can see where this could become a dangerous positive feedback, okay? If your blood flow starts to drop, your blood vessels dilate to try to increase blood flow to the organs, right? What's that going to do to your blood pressure? It's going to drop more, right? And that ultimately is actually what kills you. That's vascular shock, okay? And then the blood pressure just goes to zero, okay? And at that point, heart attack, and you're done. Which is why in an emergent situation, what's the first thing a first responder will do in response to a hemorrhage? All right, well, the first thing is they're going to try to stop the bleeding, or at least stem it. Second thing is they're going to run saline into you, just to bring your volume up, all right? So we don't have that positive feedback set up in the body. They don't care too much about blood at this point. They just want to get some volume into you, okay? Okay. That just is